Welcome to solverfy.
.56. So we're told we have a thin film in air with a thickness of 272.7 nanometers. We're told that there is a fully constructive maximum at a wavelength of 600 nanometers, and we want to find the wavelength at which we'll have destructive interference. And we also need to pick an n for this that is possible and that is physically reasonable. So, to figure out the index of refraction, which is what we need to do first, we're told we have constructive interference, and in this situation, that will have this condition. And here we've saved a little bit of bother by rewriting this with an integer k, which must be odd. This is sort of the same thing as, this would be like 2m plus 1 for m equals 0, etc., and then a 1/2. Also, I forgot the n here, because lambda in the medium with index of refraction n is its wavelength in air or vacuum divided by n. So we rearrange this for n. We have k lambda over 4 L that's preferably not completely tilted. And so putting in our values for lambda and L, we hopefully know what 4 is. So this is 0.55 times an odd integer. Now, we know that n has to be greater than 1, otherwise we're in real trouble. And so k can't be 1, otherwise the speed of light would be faster than it is in vacuum. And that's not a property that any known material has, and as far as we know, shouldn't be possible at all. 3, if we put in 3, we get n equals 1.65. And this is a pretty reasonable looking value. We've seen a lot of materials whose index of refraction is somewhere between 1 and 2, so we're going to go with this, since this is the smallest physically possible value it can have. So now our condition, now that we have an index of refraction, our condition for destructive interference, well, we have it right up here. And so we will have lambda is going to be 900 nanometers divided by some integer. For destructive interference. So if we set the integer equal to 1, we get a value that's outside of the visible range. If we set it equal to 3, it's also then outside the visible range, but sort of on the other side. So setting our integer equal to 2, we get 4 450 nanometers, which is definitely visible, and is also our answer.